Good afternoon, Nimishka, good afternoon, Janil, good afternoon, Akshita. Thank you for responding. Let's start today's work. We are doing acoustics, and in the last class, we spoke about human hearing properties and parameters, and we have seen that how the hearing parameters or hearing properties responds to stimuli in a very logarithmic manner. So today we are going to talk about the logarithmic scales that we use for calculation of sound levels, sound intensity levels, etc. We have already spoken about this in the revision and it's largely the same. So let's go ahead. So today's class, I have requested all of you to sit with pen and paper. I will give you small calculations which you can do it and perhaps post me the answers so that you are done with these topics along with the lecture itself. So we are going to talk about the decibel scale. We are going to talk about how does the sound energy spread from a point source, and we are going to talk about sound pressure levels. So going ahead, decibel scale, it is difference between the two power levels. So if there are two sound intensities, one is having the power W1, sound sources, one is having the power W1, other one is having the power W2, then the difference between their power levels, delta L is L2 minus L1, is defined as 10 log W2 by W1. Here logarithm is up to the base 10. So do remember it's not written. Normally if it is log, it is assumed to be of base 10. If it is ln, then it is assumed to be of base e. So please be careful. Remember, I am using the word power level as a single representation. I'm not talking about the power. This is not the difference between two sources, two power sources. This is not the difference between the power of the two sources. It is the difference between power levels. So I can define power level by using something which is similar, 10 log W by W0, which is sound power level. W0 could be a reference value, and we normally take this reference value as 10 power minus 12 watt. I think we have already spoken about it earlier, so I don't have to get into details. Just in short, this is the minimum power per unit area that is on an average audible to human beings. So that gives you W0. So you can use this to calculate the power levels independently, and when you say difference between the two power levels, then you subtract the L2, one equation for L2 from a similar equation of L1, find the difference, W0 you know cancels out and you get W2 by W1. So let's take our first simple calculation today. What is the decibel gain of an amplifier if an input of 0.01 watt gives an output of 10 watt? Remember, this is an independent of sound. So can you people simply calculate and tell me the answer? What is the decibel gain if input is 0.01 watt and output is 10 watt? So you can see it's a very simple calculation. Your W1, which is input, it can become one of the values. W2, which is output, can become the other value. You can divide. After division, you can take log, and after taking log, you can multiply by 10. Yeah, so that answer will turn out to be 30 decibel. That's right. That's right, Atharva, Devesh. Thank you. Let's go ahead. I'll give you another simple calculation. What is the decibel gain of an amplifier if an input of, oh, it's the same thing, got copy pasted twice, sorry. So let's go ahead. The shortcuts that you can remember here, that power ratios 2, 3, 4, 50, 10, 100. Decibel gains are 3, 5, 6, 7, 10, 20. So as we have discussed earlier, human response to stimuli is such that the stimuli increases in multiplication, the response increases in addition. One such scale is a logarithmic scale, and the one we are using is decibel gain. So this will increase in addition, this will increase in multiplication. So for example, if the power gets doubled, it's a 3 dB gain. Do remember this. If power gets tripled, then it's 5 dB gain. Remember, if from power increases to 4 times, it is just a gain of 6 decibels, so on and so forth. So just do a calculation. What is the decibel gain when the power gain is 400? Can anyone tell me orally? You don't even have to lift your pen and paper. Just look at this and you should be able to answer it. Power gain is 400. What is going to be your decibel gain? So the key idea, as I had told you earlier, that if this is multiplication, this is addition. So multiplying what would you get 400? So if you multiply 2 times, 2 into 2 will give you, I think that's very high, Akshita. Let's try it again. If you as I told you, power ratios increase in multiplication, decibels increase in addition. So power ratio, suppose I want 100. So how do I do? So 2 into 2 will give you 4. 4 into 10 will give you 40, and 40 into 10 will give you 400. So you can see 2 into 2 into 10 into 10 will give you 400 power gain. So you are multiplying this figure 2 times. To get the decibel gain, you have to add this corresponding figure every time when you are multiplying. So when you say 2 into 2, this will become 3 plus 3. When you say 10 into 10, this will become 10 plus 10. So you do 2 into 2 into 10 into 10. Here you do 3 plus 3 plus 10 plus 10. That will give you 26. So that's right. That's right. Roshni, Maria, Nimishka. Nimishka, no, not 80. Atharva is 26. That's right. So think about it. This is your stimuli. This is your logarithmic scale that is converting it into an addition scale. Now, just like sound pressure level, we can define sound intensity level. Sound intensity level, we all know L1 can be defined as 10 log I by I0, not sound pressure level, like sound power level. So we have just talked about the power level. Now this is sound intensity level. Remember, intensity is defined as power passing through per unit area. placed normal to the passage of the wave. So the definition is 10 log I by I0. So let's take a simple problem once again. What is the sound intensity level at which the sound intensity is 10 power minus 4 watt per square meter? So can you try to solve this? Remember what was our reference level in I0? Again, if you recall, it was 10 power minus 12. So this is my I, and my denominator I0. Let me show you the equation. Denominator I0 is 10 power minus 12. This value has been given. This value is 10 power minus 4. So 10 power minus 4 divided by 10 power minus 12. What do you get? That's right, Atharva. 10 power minus 4 divided by 10 power minus 12 will give you 10 power plus 8. Now, if you take a natural log of 10 power plus 8, you will get 8 log 10 to the base 10. Not natural log, sorry, log to the base 10. So, log of 10 to the base 10 will be 1. So, eventually you will get 8 multiplied by 10, you get 80. So, your gain, decibel gain is going to be 80 dB here. Now, remember, the sound starts from the source and spreads in all possible direction. If you have an ideal point source of sound, and if you have an isotropic medium, will isotropic means the medium has the same properties in all possible direction. All it means over here is the speed of sound is same in all possible direction. So if the point source, if you have point source and if you have isotropic medium, then in that case you can see that the sound spreads out in the form of spherical wavefronts surrounding the point source equally in all possible direction. Whatever power is emitted per unit time, as the time progresses, the power goes on spreading over this entire area, but this area increases with respect to r square, and therefore intensity can be defined at, for any radius, intensity is defined as the watt per unit 4 pi r square. And if you do more mathematics, algebra, etc., you will find that this ratio remains the same irrespective of the position of the source inside the sphere. Now what this tells us, that if you have a point source in an isotropic medium, then the intensity would be inversely proportional to r square. That means if you increase the radius, if you go farther, the sound intensity will drop. If the sound intensity drops, the sound decibel levels will also drop. Sound intensity levels will also drop. Remember that. So let's do some simple calculation. Sound intensity, no wait, just look at some simple calculations. Sound intensity level decreases by 6 dB, 6 decibel drop each time the distance from the sound is doubled. So do remember that whatever sound source you are having, it doesn't matter whether you are a 1 centimeter or um, say 10 meter. If you double the distance, you will get a 6 dB drop. So if at some point sound intensity is say 46 dB, if you get to double the distance, get away from the source by doubling the distance between you and the source, it will drop 6 dB. So do remember that, they are very handy. At 1 meter, if you just go, it is minus 11, it's 11 dB drop. At 2 meters, if you go away, it's 17 dB drop. However, these calculations will not hold for a hemispherical field. Most of the time, ideal point sources of sound in general are not available. In particular, if you are close to the sound source. If you are far away from the sound source, maybe you can approximate. Just visualize and think, and you should get the answer why. But if you are close, if the source of sound is kept on a surface like an alarm clock, mobile alarm clock ringing on a table, or something like that, then the hard surface at the bottom would reflect the sound up. So all the sound intensity now then evolves in a hemispherical manner. In that case, 1 over r square rule will not apply. This becomes very contrary if it becomes a softer surface at the bottom. If the softer surface is there at the bottom, then it will absorb lot of sound energy. A softer surface is something like a cushion, like a uh, bed sheet, uh, carpet, whatever. Something which has large surface area, where once the mechanical waves get into, they have no way to get them reflected. Reflections are, even if reflections are there, they are very uneven reflections. So be careful. Then 1 over r square rule may not apply. In fact, it will be very interesting to see that what rule will apply if your source is not a point source, an ideal point source of sound. And this we are going to examine in our first experiment next week. So please read this part of the theory before you get into the practicals. So I have another problem here for everybody. If a trombone bell has an area of 0.1 meter square and power radiated from the bell during every loud note is 1.5 watt, what is the average intensity and sound intensity level at the bell? So try solving this. You can write down the things. Area is 0.1 meter square. Power radiated from the bell is 1.5 watt. Now you have to do your calculation at the bell. That means very close to the bell. So what will be the average intensity? So when you are very close to the bell, you know that the sound waves will travel perpendicular to the surface of the bell, and all the sound will be perpendicular to everywhere on the surface of the bell. So you can divide 1.5 watt by the area, assuming that wherever the waves are coming out, the direction of propagation of wave is perpendicular to the surface area of the bell. So what is the answer to the first part with unit? Can anyone tell me? Oh, 132 dB, my dear, would be the answer for the second part. I'm asking what is the average intensity? 132, yes. 132 is the correct answer for the second part. First part is 15 watt per meter square. That's correct. So area is given. You divide 1.5 watt by zero point 0.1. You will get 15 watt per meter square. That will be your I. Remember, your I0 is 10 power minus 12. You divide by that, take a natural log, multiply by 10, and you get your answer in dB. So thank you Akshita, thank you Rishikesh, thank you Devesh and Clinton and Elvine. Let's go ahead. Now remember, we started talking from power and power level. Then we came to intensity and intensity level. Now I'm talking about sound pressure and pressure level. Intensity and pressure are related by this equation. So if you have pen and paper, you may even write it down. P is the pressure, I is the intensity, and rho is the density of the medium, and C is the speed of sound in that medium. So if it's the air, the density is around 1 kg per meter cube, something 1.2, 1.3, something like that. C is 340 or something. If you multiply at normal temperature pressure, you get a figure of somewhere varying between 410, 420. For all practical purpose, we will take this figure as 400. Okay. So now, if you do these calculation, put in this equation, and then put back in the equation for sound intensity level, you will get something called as power intensity level. The power intensity level, and if you want the details, look at the reference. Power intensity level is 20 log P by P0. Remember, why do we get 20 here? Think about it. In the intensity equation, we get 10, but if you look at the formula, I is proportional to P square. Since it is proportional to P square, when you take the log, that 2 will pop out, and that will multiply to 10 to give you 20. So when you are looking at sound pressure level, it is 20 log P by P0. P0 has a different value although. So please write it down. The P0 will, now it's by using all those 400 and other calculations. And as I said, check the reference for the detailed calculation. P0 will come out to be 2 into 10 power minus 5 Newton per meter square, which is 20 micropascal. So let's make some simple calculation again. What sound pressure level corresponds to a sound pressure of 10 power minus 3 Newton per meter square? Under root 400? I don't think so. We can talk about this after class if you have a doubt. What sound pressure level corresponds to a sound pressure of 10 power minus 3 Newton per meter square? So of course you can divide it by your P0. P0 turns out to be 2 into 10 power minus 5. So you take the ratio, that will give you zero point 0.5 into 10 power 2 or 5 into 10. Then you take a log, and after taking the log you multiply by 20. So what answer should you get? The answer that you should get here is around 34 dB. So please check. 33.97 Rishikesh. Yes. So 34 dB. So that's a good answer. That's right. 34. Yeah. How much force does a sound wave at the threshold of pain or pain threshold exert on an eardrum of diameter 7 millimeter? So let's take a little bit more exhaustive calculation. That's right, that's right. Remsen, Gamer, Akshita, it's, you are very close to 34. We can take that round figure as 34. Let's go to the next problem. So here the pain level is given. It's LP. Remember the sound pressure level as 120 dB. That is your sound. How much force will it apply on the eardrum of the diameter 7 mm? So how do you do this? Yes, Clinton, 34. How do you do this kind of calculation? So you can see that LP is known to you. You can put in the decibel formula 20 log LP by L0 or P by P0. You can put there, you know the value of P0, and if you do your simple calculation, that will yield the value of P. You will get pressure. Once you get the pressure, let me know how much is the pressure. Once you know the pressure, you can calculate the force acting on the eardrum. For that, you will be using area of the eardrum. Diameter of the eardrum is 7 mm. So radius is 3.5 mm. Remember to convert it into meter, and pi r square will give you the area. 3.5 into 10 power minus 3 whole square into pi. That will give you the area. How much is the pressure? My calculation, yes Akshita, my calculation also yields the same value, 20 Newton per meter square. So if you have 20 Newton per meter square of pressure multiplied to what? Uh, Pi into 3.5 into 10 power minus 3 the whole square, that will give you your pressure. So figure out how little or how more is your pressure. Devesh, I did not get 7.7. My answer is slightly different. 20 Newton per meter square is yes, that's what I got. 20 into pi into 3.5 into 10 power minus 3. So my answer turns out to be 1.5 millinewton. 1.5 millinewton. That's right, Namishka. 1.5 into 10 power minus 3. Yeah, so that is what you will be getting. Yeah, that's right. What is 7.69? I don't think so. It is that. Please check your calculation, Rishikesh. There is some difference. Okay, now sound pressure. These are different pressure levels of different situations in life. So jet takeoff construction site is 120 dB, 110 dB, and loud shout. If somebody close to your ears and shouts loudly, 100 dB, these are all intolerable. You will find that all construction site workers, professional workers at construction site, or jet workers, those who are working on the airport, they all use noise cancellation headphones, or they are using a special earphones which blocks the noise. So that is there. Very noisy is heavy truck, urban street, automobile interior. They are very noisy. Towards the end of this course, we are going to discuss noise and its impact in detail. And at that time, you would realize a very important thing. I'm just giving you a hint that exposure to noise has very precise calculations. The longer you are exposed to a noisy environment, the more your capacity to hear things, your loudness sensitivity diminishes. So don't think that if you are staying in a louder environment, if you are listening to your TV loudly, if you are listening your music loudly, then don't think that चलता है इससे कोई फर्क नहीं पड़ेगा. It is not that case. If you are using headphones etc., see to it that you keep the volume at the lowest possible value. You would surprise that if you lower the volumes of your headphone, how quickly you will get adjusted to those new levels of sound. Don't use your headphones in your if you are in a noisy environment, because in that case you tend to increase the volume further, which actually very damaging to your ears. It is not just the momentary exposure, but long exposure also matters. So please take care of that. And once we get towards the noise chapter, we'll discuss those topics in detail. These are the other one: automobile interior, moving automobile, obviously 70 dB, normal conversation 60 dB, normal office 50 dB, classroom 50 dB. I doubt. My classrooms never are never at lower than a normal conversation, because I know, because I always need to shout in a classroom. At home, the dB levels are less. Broadcast studios are 20 dB. Rustling leaves, unless you go to mountains on a trek, you are not going to hear it in an urban scenario like Mumbai. So go there and you will experience. And that's the beauty of going out of urban jungle. Now, I'm stopping here. I'm purposely not taking some kind of problems and I leave it to you. One special type of problems is that what happens when the more than one sound sources are present. So just to give you an hint, when there are more than one sound sources, intensities add up. So if you have I and I, two sound sources, you will get 2I. And then think about it, how what will happen to your decibel calculations. So from multiple sources, if the sound is coming, please practice those calculations as well. As I said, this topic, or this is just another revision of the topics covered in FY. We are actually also, this lecture will also help you towards the today's exam. Please appear for the today's exam. It is an exam just to check your baseline knowledge of the topics, which is important. Plus, it is also an exam that will give you a mock test kind of thing to use and understand how the Canvas app works with you. Thirdly, it will also help me to know how your registration on Canvas is done, if it is done or not done. So if you don't do the exam, then it's very dicey. It's I will assume that you have not joined Canvas or something like that. If you give the exam, I will have an opportunity to check all the parameters if they are correct, whether your name is right, UID is right, roll number is right, etc. etc. Please appear for the exam. Somebody was asking about the consequences. Remember, it's a baseline test. It is designed to check your knowledge, basic knowledge. It The scores that you will get here will not be added to your final scores definitely, but still it is very important. Also, exam starts at 5 o'clock. I will create a group on Google Meet at around 4:45. Those who want to uh, join, please join. Um, the exam starts dot at 5, ends at 5:30. Very importantly, don't leave your canvas screen once the exam begins. Every time you leave the canvas screen, the canvas takes a note of it and it informs me that you have left the screen. Every time you leave the screen, I will subtract minus, I will subtract zero point 0.5 marks from your total. So please, once you start the exam, don't stop it. Just in case your network is not working, you again Canvas will let me know. Once you restart, you just start from the point where you had ended. Whatever responses you would have been added before the network has gone, that would all be saved. Exam starts at 5 sharp. It will stop at 5:30. It is You will need a passcode. I will give you on your WhatsApp at around 4:50, 4:55. So the passcode will be available. You enter it, even if you enter the passcode early, exam will not begin early. It will still begin at 5 sharp, end at 5:30 sharp. There is no manual intervention in the exam. So, like if you go, if you want to go to 5:31, 5:32, it will not be possible. So, with these words, I will stop right now. Thank you. I will create a small, uh, for small time, I will create a Google Meet right now. And if you people want to join, please join.